Hello everyone. So this is the continuation of the control system video series. So in this video, we are going to till now we discussed about the transfer function modeling of a electrical system separately, mechanical system separately, and a mechanical and a rotational system. So we discussed initially a mechanical system, and after that a mechanical rotational system, and after that an electrical system. Okay, so that is a system. That means it is a very basic modeling of that function. But now we are going to discuss about a motors. Okay, so in that first what is a very useful one and very advanced one is the with a very low cost, and that one is DC servo motor, transfer function of a DC servo motor. So the topics which are going to covered in this entire video will be related to what exactly the DC motor, what is the importance of that one, where we are using that one, and how it is how it can be controlled, and what exactly that inside that equation, or what how exactly the transfer function can be built on the for the DC servo motor that we all discussed in this complete video. Okay, so DC servo motor. DC servo motor simply it will be look like this. If you see this one, it is a very low, very small. That means it is in this much of size. Okay, it is in this much of size, and it can operate that whatever these wings are. These are the wings which can operate like it is either in a clockwise direction or in a anti-clockwise direction. It can be rotated in a degrees wise. It can be rotated in 90 degrees clockwise, 90 degrees anti-clockwise, 180 degrees clockwise, 180 degrees anti-clockwise, moving forward, backward, each and everything can be done, which mostly these servo motors are very low power based motors, and also very low cost, and also low space. So that's why they are used in very advanced applications. So one of the most advanced application is the robotic arm. If you see some robotic arms will be there like to pick up and everything. So robotic arms will be there to move the things like it as in the structure in the different way. If you see the robo movie, it is rotating like that, like continuously it is rotating this degrees. That means that can be done like this type of things only, not like other type of things, which is a very fastly it can be done, and also it can be easily controlled. Okay. And the next one is what is the digital room. It is a basic, a very vital component in the both robotics and also aerospace also. Why I am saying about aerospace means, if you see the drone structures, like whatever, if you see these are the you already know about the drones, right? So the very advanced applications of drones, in these drones whatever this structures are there like wings or the movement of the thing, so that can be operated through a servo motor itself. Okay, so that is also this type of servo motors, but it in a very different perspective, not exactly the same power. It can be having a little bit of higher power also can be possible. So these type of applications it can be useful mostly in robotics and in the aerospace industry. Okay, so if you see, this is the complete internal block diagram of the complete of a DC servo motor. So the rotor and the water, however this gear system will work, and that final gear system, these are the cross arms we will say. Okay, so these cross arms can be controlled by a control system. That control system can be controlled with respect to the transfer function. So now we are going to design a transfer function. So what is a DC servo motor means? The definition of a DC servo motor. A DC servo motor is it's a one type of DC motor enhanced with a feedback and a control. It can be controlled, and also it can be enhanced. It can be improved the efficiency, improve the operation, improves the thing. It is used to achieve accurate control over the position, speed, and torque. So these are all the things can be possible through a DC servo motor. Okay. So if you see, this is the complete block diagram of a DC servo motor. So mostly the DC servo motor can no need to operate very high controller also. You can operate simply with the Arduino platform, that is Arduino Uno or Arduino things like very low cost. It is like the motor can be cost about 15 rupees, and the Arduino platform can be cost about nearly 200 rupees or something. So that in that case itself, you can able to design we can able to design a robotic structure. We can able to design a robotic operation, each and everything. So that's why many low cost applications, how they are doing, how the drones are coming with the low cost means, they are using very less of the this potentiometer is having a very low cost, and the whatever the control platform this Arduino is, and it is also having a very low platform. So that's why that's how this control these are controlling, but they are not very much efficient. So if you want very high efficiency, then automatically you need to move to the higher cost and higher capabilities. So okay. Now we will see the transfer function. What are all the requirements for the transfer function? So transfer function means the relationship between the input voltage and the motor angular position. That means the whatever the voltage it is feeding to the motor, and also the whatever the arm it is rotating, like either it is in a clockwise rotation or an anti-clockwise rotation, or this type of vertical or horizontal, wherever we are placing, according to that one it will move. So that everything will be related. So that is how the transfer function. So it will need to have the both input and output. So input will be the voltage and the output will be the motor's angular position. That means the what are the cross arm will be there using a Laplace transforms and motor dynamics. So these are the things. Now I am showing you the block diagram of that one. So if you see the block diagram of this one, a single phase supply which is going to work with this one, and this is the motor. Whatever the here, if you see, there are two torques will be there, like one is the motor torque and is the load torque will be there, and the flux will be there, and the inertia will be there, and the angular position will be there. This is the angular position, inertia, flux, torques, motor torque, and the whatever this controlled winding, these controlled windings will be affecting on the rotor position. So that rotor position wherever it is moving, then automatically what will happen is either if you want to control it in a very controlled manner, means you can able to control, either if you want to flexible control, you can able to do the flexible control also. This way it can able to do. In the next video we will see what exactly the mathematical equations for the transfer function of this total DC servo motor. Thank you.